All right, I had tried to do 3B on the previous video, but I accidentally hit something that messed it up, so I'm going to continue it here. So in the previous video, we had talked about how if we can make these equations look something like the one I've written over here in the upper right corner, um, we had factored actually 2u squared plus 5u minus 3, and we saw that it factored into 2u minus 1 times u plus 3. So we had done that on the 3a video, and you could have either used a guess and check or factored by grouping to do that. And so what we were noticing about number 3 is all three of the problems on number 3 actually are in this pattern. We just used u's instead of x's. I just put x's here just so I could kind of recap really quickly and make it look like something you've seen before. This problem on 3b is the same problem if I do one little thing, and that is let's let u temporarily equal y squared minus 4. What we're looking for is, okay, this is right here and it's also right here. If I took it out and called it something to make it look a little easier and I kind of fake my brain out a little bit, I can solve this by calling this 2u squared plus 5u minus 3 equals 0. And the advantage to doing that is that's easier to factor and your brain doesn't freak out so much. It's kind of like learning how to take a big problem and to split it up into pieces so that you're not so overwhelmed with it. Well, we can see this is just like the problem I wrote up here in the right-hand corner. This would factor into 2u minus 1 and u plus 3. Okay, so that's our old factoring stuff coming into play there. Now, that's not really the problem I had, though, was it? My real problem, it didn't have a u in it. It had, in place of the u, it had y squared minus 4. So here's what I'm going to do. I'm going to go back, and everywhere I see the u, I'll put back in what it was really supposed to be. It was really supposed to be y squared minus 4. So let me go stick that in everywhere I can. And if I want to solve it now, I can just say, oh, I've got two things that multiply to give 0, so I could set each factor equal to 0 and solve. Well, before I really want to do that, I want to kind of clean this mess up. This is kind of a messy thing, isn't it? So let's distribute and kind of clean up each parentheses. 2 times y squared would be 2y squared, and 2 times negative 4 is negative 8 minus 1, so that ends up being 2y squared minus 9, okay? Now over here, this other one, y squared minus 4 plus 3 would actually be y squared minus 1. Okay, so these are actually the two things I want to set equal to 0. I'd really want to clean those up before I go do that. Now these are going to be kind of, not pretty answers, but they're doable. At least the first set is not so pretty. If I add 9 to each side, I have 2y squared is equal to 9. And then if I divide both sides by 2, I get y squared equal 9 over 2. Now I'd have to square root both sides. And when I do that, I need to put a plus or minus on it. I'm kind of running out of room there, so I'll squeeze it in. So we would get y equal plus or minus. Now, the square root of 9 on top would be 3, but then on the bottom I'd have square root of 2. And I would need to rationalize that by multiplying by square root of 2 over square root of 2 to make my answers presentable. And so that would give me plus or minus 3 square roots of 2 over 2. Those are some of my answers. But I have another thing I need to look at for my answers, and it was this other factor. And if you look at that, y squared minus 1 is actually a difference of two squares. I could say it's y minus 1, y plus 1 equal to 0. So then I said each one of those factors equal to 0. Y minus 1 equals 0, and then y plus 1 equals 0. Hard to read that, kind of cramming in here. So if on the first one, if I add 1 to both sides, I'd get y equal 1 as a solution. And on the second one, if I subtract 1 from each side, I get y equal negative 1 as a solution. So I know it's hard to read some of that, but the stylus is what it is, okay? Now you've got one on your test like 3C, and it also follows the same factoring pattern, 2u minus 1, u plus 3. Let me go to a new slide. So 2u minus 1, u plus 3. let's see what it looks like. This is actually one much like a test problem. And I would think it might throw some people for a loop just because of the weirdness of the way it looks. C says 2y to the minus 2 plus 5y to the minus 1 minus 3 equals 0. Well, in this case, what do I have? How can I do this? Well, what if I let's look, here's, basically where I can see what I need to let u equal right here. U equal y to the minus 1. If that's u, what would u squared be? It would be y to the minus 2, okay? So this is the same thing as 2u squared plus 5u minus 3 equals 0. So I'll know it's going to factor like this up here that I wrote in red, 2u minus 1 and u plus 3. Okay? But I didn't really have u's, did I? What did I really have? I really had y to the minus 1. So that's going to be 2, and I'll write it in green just to show you that I'm sticking it back in, y to the minus 1 minus 1. And this one over here will be not a u. Why did I do that? Let's see if I can undo that. Yes. Okay, so this one would be y to the minus 1, because u is y to the minus 1, plus 3. And again, if I want to solve them, I set them equal to 0. Well, let's clean that up before I go set them equal to 0, because that may be freaking us out a little bit. Y to the minus 1 is really just 1 over y. Remember that negative exponent moves it to the other side of the fraction bar and makes the exponent positive. So it would be 1 over y, and over here this one would also be 1 over y. And this 2 times 1 over y would be 2 over y minus 1, and then this would be still 1 over y plus 3 equals 0. So if I want to solve this, I'm going to take each factor and set them equal to 0. Let me kind of come over to the side here because I'm about out of room. Okay. So if I take that first factor, 2 over y minus 1, and I set it equal to 0, I could add 1 to both sides, and that would give me 2 over y equal 1. And I could do this a bunch of different ways, but hopefully by now that you're seeing that if I have a fraction on one side and a number on the other, I can turn that number into a fraction and say, oh, it's a proportion, and I can cross multiply. Y times 1 is y, and then it's equal to 2 times 1, which is 2. So this one gives us y equal 2. Now 1 over y plus 3, let's see if I can fit it down there in that space right there. Or let me just go to the next slide. 1 over y plus 3. So we already know that we have one answer of 2. Let me go ahead and make my answer brackets over here and list my answers. So let's subtract 3 from each side. And we get 1 over y is equal to negative 3. And it's like, I'm thinking, okay, I've got a fraction on this left-hand side. Let's make the right-hand side a fraction. And again, we have a proportion, so we can cross multiply. Negative 3 times y is negative 3y. And then on the other diagonal, 1 times 1 is 1. Now let's solve for y and find out what our answer is. Y is multiplied by negative 3, so divide both sides by negative 3. And you get y is negative 1/3. Some of you may be able to see those answers without actually doing that solving step there, and that's fine. If you can go from negative 3y equal 1 to writing negative 1/3, it's okay to skip this work right here, but I would want to see the proportion. Alright, if I were writing my answers in the correct order, I would put the negative 1/3 first and then the 2. Now, this would be my answer. You do have something much like this on the test. I think the factoring is a little easier on it. It's not one where you have like a number in front of your x squared term when you factor, but you have these negative exponents, so make sure you understand how to do this one for the test.